Good morning, everyone. This is Aditya Avati again from Avati Zone. I know it's been a long time. Wait, what happened to me? Why am I Stickman? Where are my fingers? Why do I have only three fingers? Haha, jokes apart. Today I'll be showing all of you how you can build a human pose detector. And by detector, I mean that it draws lines and polygons around your eyes, mouth, nose, stomach, legs, etc. As you can see here. This is a basic boilerplate which you can use to make future video video capture and processing projects. By using such pose detectors, you can do something like a exercise counter or maybe a mouse pointer which follows your finger wherever you go. You can make many such projects, but this will be the basic framework. So today, let's actually see and learn how we can design and make such a project. Let's take a look at a demo of how our human pose detector works. In the results or in the window, we will be able to see that the animated figure which uses CV2 and media pipe will follow the exact same steps as I do. Let's start. So now we're back in PyCharm. This is where the code is written, which is approximately 45 lines. So now I'll explain to you how the logic works and how I've written this program. I've also mentioned a link in the description to my GitHub page, which has this entire program in it. So first, let's start with the libraries that we have imported here. Starting with CV2, which is the OpenCV library used for capturing videos, images, and then later processing them by using advanced capabilities. CV2 is one of the most popular and widely used libraries for such video capture and image capture purposes. Next, the media pipe library, which is a library which uses ML models or machine learning models in order to identify body poses, face detection, landmarks, along with the hand detection, along with its landmarks. It's developed by Google, who have created and trained the ML models used for it. It is also one of the most widely used and advanced and accurate libraries that you can find in Python. Next, the NumPy library, which is used for computing mathematical operations. So, moving on, the MP pose or the MediaPipe pose library, MediaPipe pose variable. Here what we do is use the pose tool of the MediaPipe library, which allows for the detection of the poses of the body that I showed in the video's intro. Did you notice, friends, that here we have written MP instead of MediaPipe? This is because we've shortened the name here by using the as keyword, as MP. Next, we call the pose object of the MediaPipe library and get it ready. Next, the MP drawing, that is again media pipe drawing variable, contains the drawing utils required. These are the utils that we use for the body tracking, that is shown here. As you can see, it's the program which finds the landmarks and draws shape image lines and shapes on them. Next, the CV2 dot video capture. This starts a video capture by using the CV2 library, which accesses the camera. Here 0 is mentioned as in camera number 0. For now, this is linked to my external camera because my main integrated camera is being used by the recording application. Next, the width and height variables are obviously for the width and height of the capture window for both the body tracking and the raw video. Next, the cap dot set function is being used to set the width and height of the frame to the ones mentioned here. Next, the pose BG or pose background is basically a completely black background which will be put behind the pose tracking. It's basically just a black image consisting of fully zeros, as you can see here mentioned, and numpy dot zeros. Next, we'll get back to the landmarks present variable when we need it. This here, which is the while loop, is used to continuously update the video capture frame so that our body movements are captured every single second. Red comma frame is equal to cap dot read is what captures the new frame every time in the while loop. If the frame does not exist, the the while loop stops, or as mentioned here, breaks, and then the cap dot release and cv2 dot destroy all windows functions are used in order to end the program. Next, the frame RGB converts the BGR colored frame to RGB. It's just another basic function of CV2. Next, the results variable contains the frame processed with the mediapipe.pose tool, which sets all the landmarks of the body. Next, we see if the body is present inside the camera. So if there is no body and we try to find the landmarks, we'll get an error. In order to prevent that, we see if the results dot landmarks, the pose landmarks exist. If they do, we get to the landmarks present variable. This is useful when we first start the program because it ensures that the points that have been drawn before are erased. So as you can see, if there are no landmarks present, if there are no landmarks present, we draw the landmarks and then set the variable to true or here 1. When we do this, we ensure that the points that were put in the previous landmark position are erased and no longer exist. As you can see in the next else statement, if there were landmarks before or there was a body detected before, we set the pose background back to its original state of a completely black image. If this line is commented, even the points of the previous location can be seen, which will make an entire mess out of the frame. And then after completely resetting the pose background, we draw the landmarks once again. Now we're getting to the end. As you can see here, we show the body tracking window, or this window, which you can see here, which contains the pose BG background along with the landmark points drawn by MediaPipe. Then the camera footage shows the raw footage of the camera. This footage that you can see here is not of the main camera but of the side USB camera shown. The pose detector uses this camera footage in order to show us the pose. Next, the cv2.wait key function is used in order to stop the program entirely, which means that whenever I press Q, the program will end. And after it ends, it breaks once again, activating these two functions and completely ending the program normally. So, this is it, friends. This is the code programming demo and explanation of the post detector system. So guys, we've reached the end. Thanks a lot for watching this video. I know it's been a very long time, and by very I mean an entire year of not uploading videos. But now I finally found a cool project that I could show to everyone. Again, thanks a lot for watching, and please like, subscribe. Who is the